Hello guys, you're welcome back to Structures Pro, the home of software. If you are coming across my video for the first time, I will beg you to just subscribe. If you're a civil engineer, if you are a builder or an architect or even a student, aspiring to become a civil engineer, this channel is for you because I will be teaching you how to design steel and concrete structures using Staadpro. I also have plans to start uploading some videos on how to use Primavera P6 and some other software. Okay, so just stay tuned and stay glued to this channel. So this is our project we are working on currently. So we are supposed to be doing the modeling today, but this is actually a complex building. If I start this model from scratch, if I start this model from scratch, it's going to take us massive time. This video is going to be up to 2 to 3 hours because this is actually massive. So by now, if you have not you don't know how to model with Staadpro, you don't know how to do modeling and to use Staadpro at all. I have a pre-recorded video training on how to use Staadpro to design both concrete and steel structures. Even a lot of foundation designs are there, pad, spread footing, pile foundation as well. All of them are there in that package. So it's a package I am just giving out at a very subsidized rate. So just check the description and you see the link there for the ultimate Start Pro training course. So that course we walk you through on how to model with Start Pro. So you can just try that. If you are very dedicated to the course, it will just take you 12 days, which is less than 2 weeks to finish what I have there, and you'll be able to scale up your skill in this Staadpro software. You'll be able to model this particular structure when you go through that course, and you'll be able to understand a lot of basic things and some advanced things about Staadpro. So I will just do small demonstration on how to do the modeling. Just a small one. I will not go in depth. So if you pick the course, you'll be able to get the in-depth knowledge about the modeling. Modeling is one of the simplest in Staadpro. Okay, so I want to view only the ground floor under view selected objects. Okay, so this is it. This is what I want to show us. Sorry. Okay, let me highlight this and show the highlighted. So this is how it goes. So the modeling I'm talking about is simply the architectural drawing you have. If you have downloaded the architectural drawing, if you have not, I've also added the link to this architectural drawing in the description. You can download it. This is the drawing plans of this particular project. This is the architectural drawing plan and elevation. Okay, so and here we have the column positions. We have already placed them, and here we have the foundation layout. So if you have not downloaded it, just on in the description there, check for the link and go to seller and download it so that you can be able to follow follow up follow you can be able to follow us in this training. Okay, so now the modeling is simply the first thing to do when you have an architectural drawing like this. An architectural drawing like this is to identify your ground floor plan. This is ground floor plan. This is the first floor, and that's the second floor. So this ground floor plan, now you begin to now look at what you have there and establish places where you need to place your column, because that's your first responsibility as a structural engineer. Okay, so you need to put columns strategically, because your work is to make sure that this building does not collapse. And what will carry this building, they are the columns together with the beams and the slabs. Okay, the slabs will carry the loads on the floor, on each floor, and they will take it to the beams. The beams, while the beams will not take it to column, then the column will send the loads to the ground foundation, which is taken up by the soil, depending on the soil capacity. Okay, so that's just the flow. So your first action point is to establish points to put your columns, which I have already done here. But before you look at what I have done here, you can also, since you already have the drawing, try your knowledge, look at where, check where you can put columns. Your own might slightly be different from mine. You must not get exactly what I have done, but provided your own will so work out, then it's still good. You get? So now, so while doing that, you should also recognize the expansion joint. So I'm going to do a video maybe in our next class to explain this expansion joint, why we have expansion joint and why it is important and why people do it. So we are going to discuss that to detail. Okay, so now you have to also take note of the expansion joint. So now let's go to what I have done. This is the ground floor. I have a column here. This is my column position. I have another column here. These are the columns I have positioned. Okay, these are the columns I have positioned. So while I was positioning the column, I also was taking note of the distances between the columns. Of course, you have to be very careful so that you don't place columns far away from each other. Because this is a concrete building, so concrete buildings, their columns shouldn't be too far away. If you have 3,600 is fine, 4,500 is fine, 5 meters sometimes is fine, but the beam is not going to be your normal 450 depth beam. So your design will tell you the appropriate depth of beam to use when your span is more than 5 meters or up to 5 meters and above. So okay, and also depending on the load that is carrying. So I have different types of column, because I don't want it to be shooting out of the wall, because the architect didn't give it that design. So I don't want to change the architect's design and the intent in this drawing or this building. So I needed a column that is more than 225 by 225. You get? So instead of me to make it to push out of the wall, I decided to align it this way. You get? So this is why I have all this like this. Then the internal ones, I used a different size, which is about 450 by 450. Okay, as 450 by 450, because I have some massive beams on them. So I will just demonstrate one or two models, and I will allow you to do the rest. It will be your take home assignment. Just since you have the drawing, try to do the modeling yourself. So what I will have a separate video for is to show you how to do this um curved beam. I have a curved beam there, so I will show you how to do that. Because if you use the property here called curve beam to do that, it might not be able to take your load and allow you to run analysis. So these are the things you need to know. So I will just I'll go to new to create a new file, a new Staadpro file, and click on create to have a new environment. It's coming up. So this is what I have now. So what I do, which helps me to model very fast, is I use nodes to model. So just come here where you have a node number, just type 0 to start from origin, x0, y0, z0. It's very important, starting from origin. Now that gives me my first node. So you go to your drawing plan, so you have to establish where you want to be your origin. Where do you want to be your origin? Do you want this point to be your origin, or do you want this point to be your origin? So it is left to you to choose that. Okay, so if you look at our coordinate system, you see that the vertical axis is y, positive y, going up, pointing upward is positive y, x is going to the right axis while Z is coming to this axis. So you have to now choose a, a, a perfect place for you. So me, I don't like having negatives in my coordinate. So because of that, when I go to the plan, I choose this point. So if I'm coming down, it is positive Z. If I'm going towards right, it is positive X. If I'm going vertical up, it is positive Y. Everything becomes positive. But if I choose this place to be my point of origin, okay, if I'm going this direction, going up, it becomes negative Z. If I'm going right, it becomes positive X. If I'm going up, positive. So my Z is going to be negative. I don't want that. You get, so I want everything to be positive. And also I don't like using a point within the drawing to as origin, because it will be giving me some values negative, some coordinate negative, and some coordinate to be positive. So me, that's my personal opinion. It will not affect your analysis output or analysis result. So it's just what I like working with. In case if I want to use coordinates to do something, I wouldn't be battling with negative and positive coordinates. I will just know that if it is coordinates 8 is 8, 8 is just absolute figure. Okay, so I would go back to my model. I've established the first node. So this first node now is this point. Okay, so if I want to go X direction, I'll simply dimension from the center of this column to from the center of this wall to the next column. Just do a dimension. Okay, start from the center of this wall to this column. That's 3525. 3525. So this is what I would do. I will select this node, click on select activate node dial cursor, and click on it to press Ctrl C, Ctrl V. That's copy and paste. Okay, so I will use coordinates. So I'm going positive X 3.525. I hope I hope I'm correct. 3.525. Sorry, that's correct. 3.525. Yes, it's correct. So that's positive X. I'll click OK. So that point is already there. Okay, so if I want to go to Z direction, I'll come to this side. So the dimension is that's 3 meters. Okay, so I'll go back to the model and click on this. Ctrl C, Ctrl V is coming to Z direction, which is 3 meters. Okay, so I have gotten my X direction, X axis and Z axis. So this is how we are going to establish all these no column positions. You continue in X direction to get these ones, the remaining ones. That's why I said if I continue to show all this model now, if I do this model in this class, it's going to take us like 3 hours and more, because this is complex. It's a complex building. So if I go my Z direction, that is how I will create nodes for each of these column positions. You get, then even the internal ones. Okay, so for this internal one, you can just offset, and that's that. So what I would do now is I will just go and create my column. Assuming I have gotten all the column positions, the next thing to do is, or you may not wait until you get all the column positions. You can just draw your column, and okay. So but before then, let me see the height of the building. So that will give me the height of the column. So from section, you see that the ground floor is at this point. So it means that our foundation pedestal is going to push up above uh, above natural ground level by 750. That's what it means here. So it's from this line now that we have our column going up. So at this level we have 4,200. So you have to subtract 4,200 minus 750. Okay, let's go calculator. 4,200 minus 750, that's 3,450. So 3,450 is going to be the height of our column. So I will just select all the nodes, the same thing. I will do Ctrl C, Ctrl V. So I like 3.45. I like using offset to do my modeling. I like it so much. So I will now go to add beam. So so this is another thing. When you establish all the points and do this kind of thing, it's going to confuse you. You might not even know which line is which line, So but with experience, I'm going to be able to join this thing correctly. This one is to this and this is going to this. Okay, so now you can even put the beams. Yeah, so now I while putting the beams, when I created this column. I started from ground to top, from ground to top, from ground to top. You have to maintain that orientation because it's very important. So now when I'm putting the beams, I try to make it from come from origin, point of origin to the other point. So this is my origin, this point is my origin. So if I want to create this beam now, I'll come this way to this point, not from here to there. So these are also very important. It helps to align your beam orientation. So this is what we are going to do. So I've also done that. Just assume that you have established all the columns and you have now placed your beam. So the next thing to do is, okay, you can assign supports. So in this case we use the fixed support. So you can just add support, then I'll assign to the all the nodes. So assign. So the next one is properties. Okay, so now I have the size of this column is 225 by 450. So I'll go to prismatic rectangular. Okay, so YD is 0.45 and 0.225. You have to take note of the units, otherwise you'll be putting wrong figures. So I'll click okay. So now I will assign. Okay, so sometimes the software converts the values to inch and feet. So don't panic when you see something like this, like what I'm seeing here, but the figures are still correct. This is 0.45, 0.4, 0.225. But what is showing me here is in each feet and inch. What you are good. So I will assign it to view. I will assign it to view. Okay, so the next thing I will do now is I will change the orientation of some of the columns because they are not, if you check the plan of the drawing, okay, you see that where is my column positions? Okay, so you see that you have this particular one is like this, is facing the x-axis, while this one is also facing x-axis, but this is facing z-axis. So this is different with this one. So I need to now reorient it. So let me check the 3D view. Okay, so this is the 3D view. So this one is correct and this is correct. They are facing the x-axis, but I need to turn this one. Okay, so for me to do that, I'll have to use beta angle for it. So beta angle is under properties. Go to beta angle. I will create beta angle. I'll use angle in degrees 90. Okay, So I'll use 90 and I'll assign this to this, assign to selected beam. So let me now check again, view. Okay, so this is very correct now. So this is basically what you'll be doing. So you establish the column, you take it to the appropriate height, which is 3.45. Link them up with the beams, the appropriate beam. Okay, so but now the beam okay, the beam is supposed to have a different, yeah. So I have to create a property for the beam. Okay, so while you are modeling, you can just be, your beam can be 225 by 450, fine. It is your analysis that will determine the designed the required depth of beam, because the ones that are not appropriately sized will fail. So whatever you're using as your beam size is tentative. Okay, so I'll create another one for my beam, rectangular. So it's going to be 0.45. Okay, it's the same thing, even 225. It's the same thing. So but it's good to separate the beam properties from column properties. So let's still do it this way. Okay, so that is that. So now where you have expansion joints, like this place, I have expansion joints here. So you see what I did, instead of facing the column in z direction, I now faced it to x, so that this spacing here for the expansion is maintained. You get? So for you to do that, let me assume that this expansion joint is the next in my model. I hope you understand. So I want to get the expansion joint as the next one in my model. So I will just assume it is 3 meters away from this one. So I will do Control C, Control V, and I will put 3 meters here, and I'll click OK. So I have it here. So now the expansion space is 25 mm. Okay, so I will do another offset, Control C, Control V, and I will put 25 mm is 0.025. Okay, so I'll say okay. Okay, so now I have two beams there, but I'm not you can't actually see them clearly until you zoom in very well. Okay, so now, but there's another thing I need to do. The orientation of those columns are not correct, so let's view 3D to see. Okay, so this is how to treat your expansion joints in this model. So you see the columns are clashing, so that's why I actually have to face it in the x direction, like this, so that they will not clash, so that the two 25 mm will be in between the two columns. So what do? You go back to the geometry. Okay, and I will change the beta angle. That's it. Okay, beta angle of this one is two ways to do that. I can double click this, come to change beta angle and put 0, click OK, and close. There's another one. There's another one that's still active. The second one. So that's the challenge. Because they are too close, it was difficult for me to pick the particular one. So now If I check the 3D view, I will be able to see the gap between the two, which maintains my expansion joint. Can change that. Okay, so there's a problem here. We made a mistake actually. So let me take us back. I'm sorry for that. What we put in the offset was just the expansion joint, but not the actual spacing between the center to center of column. Okay, so that's why it's not giving us what we want to see. So what I would just do is I would delete one of these columns. Okay, I'll delete this. Yeah, okay. So now let's go and establish the spacing, the actual spacing between the two columns. When you come here, so we dimension from center to center. So the mistake we made was we let me get the dimension first, so I will explain. Okay, so this is 250 center to center. So the distance we input, the distance we put when we offset the column was just the expansion joint, which is 25 mm, which is wrong. So when you offset the 25 mm, yeah, the columns are going to clash. Okay, so but the correct thing is to check the distance between the center of columns. That will give you the correct offset value. So now it's going to be 250. So Control C, Control V in Z direction 0.25. Okay, so that's that. So this is what it's supposed to give me. So you see 25 mm in between. So let's just confirm the this is 250. That's what it's going to give me. Okay, so that's fine. Center to center of column. So now let's check the 3D view. 3D view shows this like this. So the gap between these two is 25 mm. So that is it. So this gap has to be maintained for our expansion joint to be effective. So in your model, this is what you do. While you are modeling your own structure, make sure you maintain this expansion joint and use the correct orientation that will enable you to achieve that. So if these columns are facing Z direction, of course you won't be able to achieve the expansion joint there. Okay, so in our next class I'm going to explain this expansion joint. We are going to have a detailed explanation of what it is and why it's necessary and why some persons use it and what some persons even think about the expansion joint. Some persons think differently about it. Some persons treat it differently. Okay, so this is what we have basically. Okay, so we can now go back to our model, and I'll be glad if you take this as your personal assignment to model the whole structure. So I'm also going to come back to show us how to get this curved beam. To get this curved beam, I will show us. I will do a specific video on how to achieve that. Okay, so just stay tuned. I would like to hear from you in the comment section. If you have finished your first floor, second floor, third floor, the whole complete model, just alert us in the comment section. Let us see your progress. Let us see what you are doing. Okay, so we are going to stop here and we see in the next one. Thank you very much.